Hey everyone, welcome to Simple GAN, your destination for simplifying complex engineering topics. Today, we're diving into thermodynamic equilibrium, a fundamental concept in thermodynamics. In general, equilibrium means a state of balance where no changes are happening over time. In thermodynamics, a system is in equilibrium when all measurable properties like pressure, temperature, and composition remain constant. This means no heat is flowing, no unbalanced forces are acting, and no chemical reactions are proceeding. Everything inside the system is perfectly balanced. Consider a glass of hot coffee. Initially, it's not in equilibrium as heat flows out. Once it reaches room temperature and nothing changes, that's equilibrium. For a system to be in thermodynamic equilibrium, three specific types of equilibrium must exist simultaneously: thermal, mechanical, and chemical. First, thermal equilibrium means no temperature difference within the system or between the system and its surroundings, implying no heat transfer. Next, mechanical equilibrium signifies no unbalanced forces or pressure differences. In a piston-cylinder device, this occurs when internal pressure equals external pressure, and the piston remains still. Finally, chemical equilibrium is achieved when there are no net chemical reactions, or the rates of forward and reverse reactions are equal, maintaining constant composition. When thermal, mechanical, and chemical equilibrium all exist together, the system is said to be in complete thermodynamic equilibrium. Let's consider some practical examples. A closed container of gas eventually reaches equilibrium with uniform pressure and temperature. However, an engine during operation is never in equilibrium. Heat continuously flows, gases expand and compress, and reactions occur, making it a dynamic process far from equilibrium. This highlights that equilibrium is often a theoretical reference condition used to simplify real systems for analysis in engineering. When a system reaches equilibrium, all its state variables like pressure, volume, temperature, and entropy become constant over time. Mathematically, this means the derivatives of pressure, temperature, and volume with respect to time are all zero. This state allows engineers to define the system with a single set of properties, forming the foundation for property tables, charts, and cycles like the Carnot or Rankine cycle. In summary, thermodynamic equilibrium means no changes over time in any property, requiring thermal, mechanical, and chemical equilibrium simultaneously. It's a theoretical but essential concept that helps us analyze and design thermodynamic systems, providing a crucial reference point for all real processes. If you've understood this concept, you've built a strong foundation for understanding energy interactions and real engineering systems. If you found this helpful, give it a thumbs up and subscribe to Simple GAN for more.